Yeah, we're checking the gap, see if it's within spec. Now I'm checking it's a tight 18 thousandths. It's kind of tight up at the end, so I'm going to square it up a little bit. It kind of grabs at the top edge. So I use a ring filer right here. And I'm just going to square it up just a little bit. Yeah, it just took a little off that bottom edge, a little on that top edge. 18, I'm not changing the gap. It was just a little tight. It wasn't perfectly even. So it was kind of like a 18 at the bottom, and then up towards the cylinder, it was probably about a 15. Now it's perfectly even. So that ring's ready to go. And now we'll go to the second ring, the oil scraper ring. Now this ring here has a dot on it. That dot should always be facing up, because this ring actually flops back and forth as it goes up and down and scrapes the oil off. This ring you can usually run a little wider. It's usually the top ring, on average, you want the top ring to be like a 19, 18, 19, and the bottom ring to be like 20, 23. This one's right at 18 as well. It feels real nice. It feels a little grabby, so I'm gonna just true it up a little bit as well. Yeah, it has a shiny spot at the bottom corner. It was kind of grabbing. It was the right gap, but it was not a true perfect. Okay, these rings are ready to go. So now we're going to put the rings on a piston. So we'll get that. Number 3 ring goes on first. This is the oiling ring. Put this one on first. And then there's 2 small rings that go around it. They have some that are foul fit. These are actually come from the manufacturer with the preset gap, but you want to make sure you check it anyways. And when you put these rings on, no matter what the gap is, like right here's your gap, you want to put this gap on the other side. You never have any of your gaps lined up. So that's the oiling ring. This ring here actually oils the cylinder. The second ring scrapes the oil that keeps it from burning and smoking. This ring, you gotta make sure it's dot up. I usually check that 2 to 3 times. I'll check it before I put it on, and then when I get it on. You can never check stuff on an engine enough. So you want to be free floating in there. Check it, dot up, so we're good there. This one has no dot, so it's just a square ring, so there's not a top side to it. Sometimes they do have a dot, and sometimes they do say top. This set doesn't have anything. Now when you install like these 2 gaps right there, you want them opposite of each other. And that piston is set.
So you do each piston the same way?
We do each piston the same exact way, in each one of its own cylinders. Piston number 6, cylinder number 6. So we'll start on another set of rings. And you do that for all 8 of them.
What's this machine called?
Boring bar.
Is this the most boring job though?
Yes.
How much you gonna bore it and all that?
30,000. It's probably take 25 out of it first, and then leave 4 to 5 in it to hone out.
Is honing also a boring job?
What'd you say? Kind of boring.
We're going to install the crankshaft. Here's the bearings that we're going to use. They're a Cleveite performance bearing. Our main caps, bolts, and rear seal. We'll show how to install the rear seal, which is a little bit of a pain on an FE. Make sure these are oil free, debris free. Now, when we was doing the tear down, the oil holes are slightly off, so we chamfered the front tube because the holes don't quite line up, so did a slight chamfer on those to help on the oiling, as we noted on the teardown. And that's a good time to do that, is on the teardown before you have the machine work, because that way any debris is all cleaned out. So first we're going to install the bearings and the rear main seal. I use a assembly lube. I like to use a graphite based assembly lube, and then I also use a motor oil at the same time. This is the thrust bearing. It's got the shoulders on it. This always goes in the middle. You see it has a notch that fits in, and then you just roll it down and push it into place. Sometimes you have to take a rubber hammer and maybe slightly tap that, but most of the time you should be able to push that down. All these bearings have a hole in them, top and bottom. I always like to clean them with my finger. You can clean them with a rag, but you'll leave lint. So just as long as you have good clean hands, cleaning debris off of your finger. Okay, now we'll install half of the rear seal. It's a two-piece. One goes in the block, one goes in the main cap. It has directions on which way they're supposed to set. And it can be kind of confusing, but the lip points into the engine. So the lip should be going this way. Now before you put that in there, I want to put a little silicone all the way around the perimeter of it. So put a little bead. And then you want to install it, the lip facing inward and offset. So you want just a little bit of it sticking past. That way the seam is not with the seam is offset. And this needs to be lubed as good as a bearing does. This little thing comes with the rear seal, and it's actually a gauge, so that when you put the offset where this sticks up, you can actually measure it and use that little gauge so you get it just right. You do the same on that gauge, it'll measure your exact depth between the block and the main cap. That way when you install the main cap and you use the silicone, when it's basically glued in there, it's not gonna disrupt the seal. Okay, next I want to put all the bearings into the caps. Here's our thrust bearing. It has a machined lip in it with a thrust bearing. First, your machine shop should number all of your caps, or you want to number them before you disassemble the engine if they're not numbered from the factory, which most of the time they're not. So you want to number them somewhere, mark them, because these cannot get out of sequence. All the main caps prepped. So I'm going to open this assembly lube. It's a graphite based assembly lube. Kind of gray, it has a graphite in it. And I also like to take oil can and oil it as well. Here's our crankshaft. quick wipe down, make sure we didn't get any dust on while it's sitting. This crank has been turned to a 10-10. 10-10 means that the main journals and the rod journals have been both turned 10,000ths and polished, and then everything was balanced. The machine shop actually marks it right here, a 10 and then a 10. So that means that the rod and the mains have both been done 10-10. Usually on a virgin engine that had never been overhauled, we'll always do a 10-10 unless it has some kind of damage. Do a quick blow through. Do a plastic gauge. This right here is called a plastic gauge, and you usually tear off a little speck of it, and it's got a gauge reading on it. And then we'll look up the spec on what the clearance is supposed to be. Open this up, and there's a little wax. It's like a wax string. We'll take a little bit of this, put it right there on the crank, like that. Take our #1 main cap. Torque wrench. We're going to torque that to spec and then unbolt it. Let's see here. Main caps are 40. This is to ensure the machine work's been done right and the clearances are correct. Just to be on the safe side, we're going to check it.
How much?
45 right now. Okay. Take it back off. Okay, you can see it squished it, and it's a small spot where it didn't was in between the bearing groove. Where it made surface, it squished it. So we take our gauge now, and you line it up to that. Looks like it's about 0.76, probably a little under that, probably I'll say 74. So we're gonna check it with our spec in our book. And we're 74, so we're right on spec. So we're the clearances is absolutely perfect between the bearing and the crankshaft. It's right on the money. So that way we know that this crank is not going to be too tight. It's going to spin properly. It's going to, once we get all the main caps on there, this thing should spin just as easy. Should not have any problem turning this. Then as you put the pistons in, it gets harder and harder to turn because you basically start to have friction from the rings moving in and up the cylinder. Now once the engine is broke in, that resistance goes away with more and more miles. If it's too loose, your oil pressure won't be proper. If it's too tight, then you're going to have a major drag issue, and you're going to have your bearings wear out way too quick. And it goes the same way with the rod journals. They need to be within spec. If they're too tight, you'll have a bearing failure. You could do what they call spin a bearing. If it's too tight, you can actually spin that bearing in the journal. Now here's your main is the narrow, the wide of the rod, because you have 2 rods per journal. The mains just have 1 main cap. An important thing when building, the bolts need to be lubed up for proper torque with a 30 weight oil. You want to put some oil on your bolts. Also note that the machine shop numbered each cap. These caps have to be with this block. They're originally machined that way. You can't take these caps off. If you lose these caps, you're basically screwed. You can't take these caps off another motor and put them on there. They have to be the ones with this motor. Our machine shop also did a line hone. So they hone, once all the caps on, they put a hone in there and hone it. That way that it's trued up to perfection. That'll also, you'll gain a little horsepower out of that because it takes off reciprocating drag of the crank spinning because it's in a perfect alignment. So it costs a little more extra money to do a line hone, but it's worth it if you're building something for power. Okay, on the rear main, these are one of the more problem areas on the FE. So you want to put some silicone between the mating surfaces, keep a leak from forming right there. Now these have a seal that drives down the side of the main. So what I like to do is actually put a lot of silicone through there. It helps it lubricate it. So our main caps are seated all the way down. We'll put the bolts in. Now the bolts need to be all lubricated with motor oil. If you're running an ARP bolt, then the ARP bolt has to be lubricated with their lubrication and their torque specs. If you use a stock bolt, you can use the Ford spec and use motor oil. Then we'll finish putting the rest of the side seals in. Make sure your bolts are in place, so your cap is in perfect position. Now the side seals have 2 driving nails and the 2 seals. Now the reasons for the pins is for install. So you can drive the seal all the way down in there, and then you install the pin with a hammer and it expands the seal once you have it installed. And it's, as you can see, very hard to push in. I can barely push it in. Now you can lube these up a little bit. The best thing to lube these to where they'll get all the way in position is with a silicone-based grease. This is a dielectric grease. It's a silicone-based grease. You just want to get a little bit of this stuff. Lubricate the seal. These are very tight to get in there, but if you lube them up, they go in there real easy. As so, you can push them down with 1 finger. Otherwise, those are such a pain. You push them in 100%. They're all the way in there. Pins go on the back of the seal towards the cap, and then we'll tap that pin in, and that expands the seal. And that one's installed. These are the side seals for the main cap. This is probably one of the more harder things that people have an issue with. But the easy fix that makes this super easy is that silicone-based grease. That makes this seal easy to install. And then it has a little bit of a hole, and you want to be able to fill this in with silicone before the oil pan is installed. Okay, I'm going to torque the main caps. The spec on those is 95 to 105 torque. I usually torque it more to the high end, so I'm going to torque about 100. I always start in the middle. I'm going to start in the middle of these.
Any sequence to this, or just one after?
Not on the mains, there's no sequence, or on the rods. The sequences are mainly on the head and the intake. As you can see, that thing spins no problem at all. It should spin super easy. If there's any binding, if this spins any harder than pushing it with one finger, you got a problem. So your machine shop screwed up. This one's absolutely perfect. It should spin with ease. Your machine work is 90% of an engine build. If your machine shop doesn't do a good job, doesn't get the specs right, you will have a major failure. Okay, now that we got the crank installed, we're going to start installing the piston rod assemblies. What I'll probably do is go over the procedure of installing one piston, all that it takes to install one piston, and then the rest is replication. Well, these have been rebuilt, so the machine shop torques the rod bolts, remachines the hole to be true, and then make sure all the bolts are good. They have no stretch in them. They install just like the mains did. They have a notch that they fit in. Then you just rotate them in. Okay, then we put these protectors on, the bolts. That way when we install the rod assembly, the bolt doesn't nick the crankshaft. So this protects the crankshaft and the cylinder wall. Now what I like to do is I use engine oil. Some guys use transmission fluid. I've always used engine oil. I've never had any problems. Of all the hundreds of engines I've built, never had a problem with just lubing everything up with engine oil. Some guys swear on transmission fluid, helps seat the rings, so on and so on. But I always use engine oil. I apply it by hand. I make sure all the rings are lubed up really well. And then I take the engine oil and I lube up the cylinder. So I do it by hand. That way you don't want to use a rag, because the rag will put lint in there. So just use a clean hand in there, lube it up real well. You can see the nice shine from the hone in the cylinder. Now there's tons of different piston ring compressors. I've always used this style. It works for about any size. It's an older way of doing it. Okay, we want to make sure our crankshaft is lined up at the bottom. You want to turn it to where the rod journal is lined up perfect in the hole, as you can see in there. Our rod journal is lined up on top. Then the piston has an arrow or a dot. This has an arrow. The arrow points forward. That way it lines up your valve release from the exhaust and intake. If it's a flat top piston, it doesn't matter which way it goes in, other than the rod does have a chamfer on it. Hold it up a little above. This thing compresses the rings. Good and tight and square. Take a piston thumper hammer. You can see it's a little different hammer, has a longer shaft on one side. That way you can actually tap the piston in. Tap it in flush. That's our first install. You could also go and take a feeler gauge and check the cylinder wall to piston side clearance. It's a 0002 piston to block clearance. If it's any more than that, you'll get what they call piston slap. That piston will sit in there and it'll be rattling around. I've seen Chevrolet guys and stuff, they'll actually bore them out more, thinking they're going to make power, and the pistons are in there slapping around. They might make a little power, but what's a piston slap? Things rattling around in a hole. Okay, now we got the piston in. We're installing the rod cap. The rod caps, they have numbers on them. This is number 1, so the 1 lines up to the other 1. You can see there's a 1 and a 1. Now we'll install the nuts and torque that to spec. Your nuts need to be lubed with motor oil and then torque to spec. I like to put the nuts on. It's kind of hard to torque it down in that hole, so I usually put the nuts on and then rotate the crank where it's up on top. See, the torque spec on the rod, 40 to 45 foot-pounds. Cobra Jet is 53 because they got a slightly bigger bolt. This is on the PI, is 45. But this is the rod bolt nut. As you can see, you can hear the drag of the rings, but it should rotate pretty easily. Now, once you get about all 8 in there, it's hard to turn it by hand. But after you put about 4 in there, you can turn it by hand. Now, if this doesn't torque to spec, you just keep turning it and turning it. Every nut should be about the same distance. I've had them on small blocks where you keep turning it, and that just keeps getting longer and longer. You'll actually twist the rod bolt. You have a bad rod bolt. So if they keep going and they don't click, you got a bad rod bolt.
I see the OKG on it. What's that mean?
It's okay, and I've looked at it. First name, Gino.
Okay, I got all the rotating assembly done. Fixing to install the camshaft, oil pump pickup, and the oil pan and front cover. And then after that, we'll install the cylinder heads. I'm going to clean the gasket surfaces for the heads. Get the cam ready to install. This is an Iskandarian cam. A lot of people are having problems right now with lifters. All the lifters are made in China. Iski guarantees their lifters will be made in the USA. A lot of people are having lifter failure problems. One thing that causes lifter failure problems is not adding this to the oil. This has to be added to the oil every oil change. What this causes is the modern oils are too slick, and this adds the friction modifiers back into the oil so that the camshaft lobes can grab onto the lifter and spin it. If this thing's not spinning, it won't lubricate correctly. The modern oils are too slick, so this gives it a friction that actually gives this lifter something to grab onto and spin it. So this is a must on all oil changes on these older motors, using a flat tappet hydraulic or solid lifter. The specs on it, it's a little bigger than stock. It's a split duration, a split lift. So it's a 492 intake and a 488 exhaust on lift, and a 281 intake duration and 278 exhaust. It gives it a little bit more breathing room on the exhaust side than the stock cam, which is what they really need. Okay, we have on the bearing mains, I usually use a bearing lubrication on those, and then the cam lifter lube I use only on the lobes. So we're gonna lube up the first lobe first. We'll put this in the block. Now we'll lube up the rest. This is a cam lifter lobe that's a high pressure grease, keeps from fouling. got a lot of the stuff in it that helps it turn the lifters. Initial break-in. On the initial break-in, when we first fire it up, you have to let it run for 2,000 RPM for about 20 minutes to do the break-in procedure on the cam. It's just engine oil. Gonna lube the bearing where the bearings run with engine oil. If you use the cam lifter lube, it wants to bind. It doesn't turn as easy as it does with regular bearing lube. This stuff's real thick. You gotta be very careful installing it so you don't nick the cam bearings, one of the lobes. You just want to take your time and work it in.
That's it?
That's it. Cam's installed. Now we got to add the thrust plate, and we'll install the timing chain and then the front cover. Okay, I'm putting the ZDDP additive into our oil using a 1030 weight Castrol GTX. Start soaking the lifters in the oil. I'll put them all in there and let them soak real good, and we'll install them. Okay, this is the thrust plate for the cam. The plate goes with the notch outwards. That way it oils the back of the timing chain. This also requires a little bit of lock thread. These are a big Phillips head screw. Test this on the way it's centered. I'm gonna put this on just to center it. Okay, I'm gonna tighten up those screws. Those are supposed to be torqued to about 15 foot-pounds. Okay, you want to install the cam pin. Now we're going to install the timing chain. Tap this on a little bit. Still right in there. Okay.
Is it on?
Yeah.
That's just a tool so you can turn it.
Well, that actually holds the balance around. But it is so that it'll rotate. Okay, next we've got the cam thrust bolt. It requires a little bit of Loctite. Line up the slot with the pinhole, and then we'll torque that down.
How much torque?
That torque's to 35. This drives the fuel pump arm. Arm will come through the side of the block and right on the bottom. And as you can see, this is like a cam, so it's slightly offset. So as this rotates, it pushes the arm for the fuel pump and allows it to pump. Okay, when you put the timing chain on, you line up the dots. Now this timing chain has 1, 2, 3. You can actually put a little bit of advance into the timing if you want. 1 degree, 2 degree, 3 degree. The ideal thing to do if you're doing a performance is to degree the cam. So put a degree wheel in and degree it. Okay, now that we got our timing set all installed, we're going to prep out and put the front cover on.
Starting to look like a motor now.
Yeah, I'll get it closed up after I get the timing cover on. Put the oil pump, oil pan, then we'll flip it back around, put the cylinder heads on.
Close. This is exactly like Shelby built it, right? I mean, it's the same ingredients, the same basic engine, right?
Yeah, this is exactly 428 PI, just as Ford built them, other than a few little modern upgrades. This engine was originally developed as an alternative to the 427. The 427 was a short stroke. This one had a slightly longer stroke. So it was built more for bigger cars to produce a more low-end torque street motor for a big, heavy car. Of course, putting it in a small car like a Mustang, you have a lot of low-end torque, and it performs really well for a performance engine. Only the Shelby had to do 2 4s, 428. Of course, there was other Fords with multiple carburetors, and earlier you had the Galaxies with 2 4s, with 427s. That was actually quite common, but as far as Mustang goes, this was the only Mustang with 2 carburetors. And I'm installing the oil pump. We're doing an upgrade on the oil pump. This is the stock oil pump drive shaft, so going up an ARP, a lot beefier, better. This is a chrome moly tube. So that's definitely a good insurance right there. So we're gonna install that. Gasket. Going with a milling oil pump. This is a high volume, so it has a little more volume than stock. Torque the bolts to 15 foot-pounds. I'm putting up the oil pickup tube on. And these are torque the same, 15 foot-pounds. Turn the rotating assembly and make sure that the crank doesn't hit the oil pump in any way. Clearance between the crank, counterweight, and the oil pump, just to make sure. It'll clear 90% of the time, but you just want to make sure that nothing's rubbing, because we are going with a slightly bigger pump and a little bigger drive. But everything clears good, so we're good there. Okay, we're checking the clearance between the oil pan and the drive. I'll put some dum-dum right there. Usually want about 3/4 of an inch, which is about how much that is. You don't want the pickup to touch the bottom of the oil pan. You want a gap, but you don't want so much of a gap that if it gets too low on oil, it'll run out of oil. So you want about a 1/2 inch to 3/4 of an inch of clearance. So we'll go ahead and button up the bottom and put the oil pan on. Check the clearance for everything. Everything lines up good. So we'll put some silicone around it. Especially want to put silicone on your mating between the covers and the block. There's a little bit of a seam that's uneven.
Now, will you paint that oil pan on the car?
Do it just like Ford did. We'll do a full assembly, and then the assembly gets painted. They had the intakes on, and they actually had like a cover that they set over the intake to keep most of the paint off the intake, but they have a little bit of overspray around the edge. Also want to put a good amount of silicone around the back where the main cap meets. Fill all that in with silicone. If everything's good and clean, you really don't need to use silicone, but it helps. Put a little on this side. Putting silicone on the between the gasket and the pan's the best ideal, because the pan could have little bends or imperfections in it that can cause a leak. So a little bit of silicone will help a bunch.
Is that the oil pan we're gonna use?
Yeah, that's it. Got date code, promo code.
Really?
There's a date code on it, promo code.
Did that come with this engine?
Yeah, that was the one that came on.
What's that?
I was putting a drain plug in. We're buttoned up on the bottom. Start putting cylinder heads on. We'll put the dowels in first. These are the line-up dowels. Go in the corners. They remove these at the machine shop in order to true up the deck and everything, just clean it up. These are what centers your head, helps hold it on while you put the bolts on. Before we put the cylinder heads on, we'll go ahead and put the lifters in. It's a little easier to put these in the head off. Just soak them in oil. They're hydraulic, so they're full of oil when you start it. We're going to put the cylinder heads on. We've got Velcro head gaskets. All head gaskets have a front that goes towards the front of the engine. And our head bolts, I usually dip them in the motor oil. They're torqued. We'll take one on each end. There's long and short. The short go on the outside of the engine, and the long ones go on the end. So the long go on the top, short go on the bottom. Boards don't require any sealer around the head bolts because they don't go in the water. They actually bottom out. So they just require engine oil. Put the head on. We're going to clean our gasket surface with a little lacquer thinner, lint-free rag. Take it on me a little bit. Short on the outside. So these are 390 heads. It's everything is identical through 390. They just have a different crank and rod in them. They're slightly bigger bore in a 390. Crank a little different, but they're share about everything with the 390. Front towards the front. You put that on backwards, it'll overheat. All these little holes for the coolant will be in the wrong spot.
What all the machine shop do to these?
To the heads, they were surfaced, so you can see this surface is trued up and straight. They were milled and surfaced on this side, so it's trued up. They don't take much off, it's just enough to make sure that that surface ain't warped and perfect. New valve job, they had to replace these two exhaust valves because of pitting. Complete new setup on the springs for our cam, to match our cam. And then of course they were cleaned and man-fluxed. Valve job. Heads are one of your more expensive things to have rebuilt out of machine shop. a little quicker. Snug them up this way. Okay, I'm going to torque the cylinder heads. You start from the middle, X pattern it out towards the outside. I have to always torque in 3 increments. The max on these is 95, so I'm going to start at 55 and then probably like 60, 70 range and then finish it with the max of 95. So I'll be torquing it 3 times. About 80. And 95.
That's it.
That's it. Got the heads torqued down, and we're going to install the intake and finish up the valve train. I'm going to install the Velcro gaskets. They hook into the head gaskets. These little hooks to keep them in place. You can do one of 2 things. You can put a bead of silicone across here, or you can use these gaskets. Since we're doing basically a concourse restoration, we're going to use the gaskets. Because if you look in the front, you'll see the gasket. Take a little pin, line up pin, goes right in here. Tap that in. What I like to do when I use the gaskets is I actually use a weather stripping glue across here that glues this in place. That way it doesn't push out when you torque, it holds it in place. And then I put a little silicone in the corners. So weather stripping glue, it dries fast and it holds in place. Put a little bead across there. If you're using a factory intake, you can use the lineup pin. Ours is a factory intake, so it'll have the cutout for that. Well, the aftermarket intakes, like Edelbrock, will not. You'll have to pull the pin out. It will not have a hole for that. Let that weather stripping glue dry a little bit. I also put a bead of weather stripping in glue on top of the gasket as well, and then more silicone in the corners. Fill that imperfection area right there, silicone. I also put a bead of weather stripping in glue on top of the gasket as well. If you have a lot of pitting around these coolant holes, it's a good idea to put silicone around them. These are pretty clean, so we're not gonna worry about those.
Is there some there?
It has some pitting, but it's been machined out. It's not bad enough to cause a leak. Alrighty, I got brand new bolts that are concourse that they used with this particular aluminum intake. The iron intake takes a slightly different bolt.
How much weight does this cut?
Oh, about 50 to 75 pounds over the iron.
And there's the part number. And then the Fomico's a big deal, right?
Proves it's a real deal one.
Because Repro's not allowed to put Ford Motor Company on it, right?
Yeah.
Is this what inspired the design of the oval air cleaner, the dual four?
The T-Birds and the Galaxies had the oval air cleaner.
Here's a 1961 full-size Ford, a Starliner, with an oval air cleaner and a set of 3 tube barrels. This is a high-performance 390. Look at the 4-speed shifter inside. This 1963 and a half Ford Galaxy, a lightweight made to drag race, came stock with dual fours. That oval air cleaner is topped by a T-Bird logo emblazoned with 427 and a pair of checkered flags.
Tighten those up and torque them to spec.
Shelby was out to top the 390 in the Mustang GT. He did so in a big way. Enthusiasts today are realizing this is the one and only Mustang ever to have multiple carbs. As the horsepower wars of the late 60s heated up between Ford and Chevy, there was an internal war going on between Ford and Shelby, with the 428 at the center. Ford was now developing a high-performance 428, but they wouldn't call it that. Instead, they would borrow a name from the Shelby camp, Cobra, and call it the 428 Cobra Jet.
Once you put that intake on, it'll never be the same.
Yeah, performance now.
You've turned a passenger car 428 into a police interceptor. Is that fair to say?
Well, we turned a 428 into a Shelby GT500. Oh, our gasket didn't move. All looks factory. We'll clean out the spooge a little bit because they didn't really use silicone in. Silicone spooge you want to wipe off. That gives it a more concourse look. We're going to torque the intake to 35 foot-pounds. And then we'll start installing the valve train, and we will be done with our engine assembly, and it'll be ready for paint. We're installing the new push rods. Went ahead and got all new push rods because the one of the push rods in this engine actually was bent. So went ahead and got all new push rods just to be on the safe side. Making sure I got them all in the center of the lifter. See down in there, the push rod's in the center of the lifter. Put the splash shield on. Now there's a one hole that's a little different, this one right here, and it has a hole for the oiling of the rocker arms. So this one also requires a different bolt. This bolt has a shoulder on it. And the regular bolt, you can see the difference. This bolt has to go in that hole or you will not have oil to the rocker arms. That's how all FEs are. This is just a splash plate, controls the oil splash. These are rocker arm assembly. These are non-adjustable because it's a hydraulic cam. So we'll make sure we got our shoulder bolt in first. Just lining everything up, make sure everything's screwing in just right. You want to make sure it screws by hand before you put a tool on it. We don't damage anything, because you can break, cross thread a bolt or get it at an angle, whopper jaw it. This came off of this engine. This one here's the oiling hole, one per side.
Are you gonna pop the valve covers on here or not?
No, not till I paint it. What I actually do is when I paint it, I have an old set of steel valve covers that I put on it to mask it off and then paint it. That way I don't have to try to tape that up. You don't want to tighten any one of them all at the same time. You gotta want to jump around because it's actually compressing the valve springs. You don't want to bind it up or damage anything. We'll just do it in small increments. Let it slowly push itself down. And then once it's all in place, go back and torque it to spec. These torque to about 25 foot-pounds. And that's our valve train complete. Now we'll paint it and finish up the detail work. Install the distributor, valve covers, exhaust manifolds, balancer, fuel pump, spark plugs, wires, so on. And then we'll be ready to drop it in the car. Okay, I'm gonna paint the engine. Got the engine masked up. First thing we'll do is spray a epoxy primer in a black over all the bare metal. The materials we'll be using for the engine today is a PPG DP90 epoxy primer for the sealer. We'll be putting one coat of that on there. I used it black because if you get it chipped or anything, you don't see a color or anything under the paint. It looks like bare metal, as they did from the factory. They just used a paint right over the bare metal. Then put 2 coats of Ford blue. Now for the color, we're using PPG Omni. That is the paint code 13358 Ford blue. This mixes a 1-to-1. It's a single stage urethane based enamel. Then we have the engine DP'd. It's been drying for about 10 minutes. Gonna let it dry for about 15 and then start spraying the color on it. I masked the intake off to where the edge of it gets a little bit of overspray. That's how they did it from the factory. They actually had a cover that went over the engine, and then the overspray kind of went around the front and the back edge of the intake. I curled the paper up to give it a nice soft edge so it looks more like overspray than a straight tape edge. Okay, let's do the first coat of color.